Everyone. In this video here, I want to focus on working several practice problems with you all from two worksheets. This first worksheet right here involves Ohm's law, and the second worksheet involves calculations with electric power. So in order to do this worksheet, I want to remind you all of an equation that I gave you all in a previous video, which is what is known as Ohm's law. And Ohm's law says that voltage is equal to current times resistance. So let me just remind you all what all three of these terms mean. So remember, if we have some sort of electric circuit, a battery connected to a copper wire, remember the battery has a positive end and a negative end. Okay, so if we have a negative end here and a positive end here, basically what that means is there's going to be a difference in potential energy between the positive end and the negative end. And that difference in potential energy is what is known as voltage. So because you have a difference in potential energy, that naturally leads to a flow of electrons. In other words, it leads to a current. So the electricity flows like this through the circuit. And of course, remember, you can add a barrier or a device to a circuit, and that barrier is what is known as a resistor. It's exactly what it sounds like. It resists the flow of electrons. In other words, you can use it to control the flow of electrons. So that's a brief explanation of those three terms, and Ohm's law tells us how those terms relate to one another. This first worksheet right here involves 10 problems. However, I'm only going to work out the first 5 with you all, just to give you guys a basic idea how to do these questions. They're pretty simple. All you have to do is just plug in your numerical values into your equations and do your calculations. So let's begin with number 1. Number 1 says a current of 3.7 amps is running through a circuit like the one above with a resistance of 1.5 ohms. What is the voltage? So, of course, voltage is equal to current, which is 3.7. So let's plug that in, times resistance, which is 1.5. And when you multiply those two together, you get 5.55 volts. So pretty easy. It's number 1. Moving on to number 2. Number 2 says if the current in the circuit above is 10 amps and the resistance is 3 ohms, what is the voltage? So once again, let's just plug in our numerical values. The current is 10. The value of the resistance is 3. So when you multiply that, you get 30 volts. So in other words, that's the value of the potential difference between the positive and the negative terminal of the battery. Moving on to number 3. Number 3 says if the current in the circuit above is 24 volts and the resistance is 12 ohms, what is the value of the current? So basically in this equation here, we got to get I by itself. In order to do that, we have to divide this equation by R. And the reason why is because when we divide, the R's will cancel. And remember, what we do to our right-hand side of the equation, we have to do to the left-hand side of the equation. Okay, and so we're just left with this. Current is equal to voltage divided by resistance, which means that in this case, if the voltage is 24 volts and the resistance is 12 ohms, that means the current is exactly equal to 2 amps. So that's the rate of charge flow through the circuit. Okay, so that's the third one. Let's do 2 more on this worksheet. The fourth one here says, given a voltage of 120 volts and a current of 5 amps, what is the value of the resistance? So we have to get R by itself. In order to get R by itself, we have to divide this side of the equal sign by I. So the i's cancel, the currents cancel. And remember, whatever you do to one side of the equation, you have to do to the other. So that means resistance is equal to voltage divided by current. So if the voltage is 120 volts and the current is 5 amps, that means the value of our resistance is 24 ohms. So that is the fourth one. Okay, last one on this worksheet. Number 5 says, given a resistance of 1500 ohms and a current of 0.03 amps, what is the value of the voltage? So here we just multiply current, which is 0.03, times the magnitude of the resistance, which is 1500. When you multiply those two together, what you get is 45 volts. Okay, so those are several practice problems involving Ohm's law. Try to see if you can do the remainder by yourself for this worksheet. Okay. Let us now move on to the second worksheet, and we're going to work out these 5 problems here. And in order to do the 5 problems on this worksheet, I'm going to have to give you guys a new equation, and that is the equation for power. And power is equivalent to current times voltage. And power just basically refers to the rate by which the work is being done by any device in the circuit. So it's energy divided by time, or in other words, work divided by time. And the typical unit that we use to express power is the watt. Number 1 says the headlight of an automobile have 2 power ratings, 45 watts for the low beam and 65 watts for the high beam. How much is the current in the headlight filament of a headlight bulb for both of these settings when 12 volts is provided by the car battery? So here we want to solve for current. So in order to rearrange this equation, we have to divide it by voltage, and whatever we do to one side, we have to do to the other. So that means current is equal to power divided by voltage. Okay, now we have to do this calculation twice. For the first setting, we're at 45 watts. And of course, that's divided by 12 volts. And for the second setting, we're at 65 watts, and that's also divided by 12 volts. For this first one, when you divide these two numbers, you get 3.75 amps. And then for the second one, 65 divided by 12 gives you 5.42 amps. So that's number 1. Okay. Number 2 says a high intensity portable lantern is powered by several batteries that are connected in series. The lantern bulb uses 96 watts of power. What is the current in the lantern, while the current in the lantern is 45 amps? Assuming that there is no power loss in the circuit, what is the total voltage of the batteries? So in order to solve for voltage, you have to divide by I. That goes away. You have to get to the other side. So voltage is equal to power divided by current. The power is 96 watts. The current is 4 amps. So that means the voltage has to be 24 volts. So that's number 2. Number 3 says a current of 5.83 amps is used to produce the microwave radiation in a microwave oven. If the voltage across the oven is 120 volts, how much power does the oven use? So here, just simple plug in and calculate. So we want to plug in 5.83 amps The voltage is 120. So when we do this, we get 699.6 watts for our power. Okay, two more. The fourth one here says a bus built in 1905 used electricity produced by a gasoline powered generator. The generator provided 33.6 kilowatts of power to the bus. If the voltage across the electric motor was 440 volts, what was the current in the motor? So before we do this problem here, we need to convert kilowatts to watts. Remember, there are 1,000 watts in 1 kilowatt. So that means if we have 33.6 kilowatts, that's the same thing as 33,600 watts. Okay, so now we have that. We can just do our math. Remember, in the previous problem, we said current is equal to power divided by volts. So if we divide this number, that number divided by 440, we're left with a current of 76.36 amps. Okay, so that's the fourth one. Last one, number 5, says a refrigerator uses a current of 0.62 amps and a voltage of 116 volts. How much power does the refrigerator use? So just plug everything in. Current is 0.62. Voltage is 116. So that means the power is 71.92 watts. So in other words, the refrigerator uses basically 71.92 joules every second, because that's what power is. That's what watts refers to as energy divided by time. Okay, so those are your example problems. If you guys need any help with something, or if you need me to clarify something, please don't hesitate to contact myself or anyone else in the physics department. Thank you and goodbye.